Hello everybody, this is second part of our series of embedded system interview preparation. Now if you haven't watched the first part, I will highly recommend you to start from there. It will take you a short time. So in this video, we will be discussing about what important topics, what important subjects you should cover for embedded system interview preparation. How you can build your strong foundation because that will be very much important during interviews. So, talking about embedded system interview preparation, I think strong basics and strong foundation of important subjects are very important. What we have observed and we have already discussed in last video is that interviewers mostly focus on basic concepts. And why it is important, because I think if we have strong foundation, we can adapt to new things very easily, and that is most important thing in industry. And another important thing is that we should know how to learn a new things fast, because I think there will be new challenges in every team, in every company, over the period of time, and it is very important to learn new things very quickly, because that will make you useful and productive for your team. And I think that is what hiring manager is looking for. He is looking for your strong foundation so that you can learn fast, and he is looking for your ability to learn fast by giving you some coding problems or by asking you some tricky questions about the basic fundamentals concepts only. So let's try to understand how we can make foundation very strong, and what kind of topics and which subjects are most important if we want to cover all the basics of embedded systems. So before starting, I wanted to talk about one important thing, that is determination. Now it will take around 3 to 4 months or 6 months if you have just started to complete entire preparation, because there will be 4 to 5 subjects you need to cover. And also if you are not very good at programming, you need to practice that as well. So your determination will play a very important role in your preparation journey. So there will be some good days, but there will be some bad days as well. But it is very important that you should stay determined, and you should not lose your interest and stop your interview preparation journey in between. And determination will play an important role over there. You should be very determined and start with a positive note, start with a promise to yourself that you will cover everything and you will prepare well in next 3 to 4 months. So on that note, let's start. Now let's try to understand what are the important subject you should cover to complete your entire embedded system interview preparation. Let's start with computer architecture. In computer architecture, you will learn about processors and their architecture. You will learn about what are the different blocks in processors and how those blocks are communicating or are connected with each other, and how they are processing your instructions to give you your desired output. So the understanding of computer architecture will help you to build your embedded systems. In operating systems, you will learn about how complex systems manages multiple tasks. And operating system is very interview favorite topic. Many interviewers will mostly ask about fundamental concepts of operating systems. You have to focus on real-time operating system as well. In embedded system, you have to understand what is the difference between operating system and real-time operating system. There will be deadlines we have to serve in embedded systems, like hard, firm or soft deadlines, and the aspect of real-time operating system will come into play over there. So you have to get some understanding of that part as well. Now talking about C programming, this is must have tool in embedded system, because the entire industry relies on C programming, and it is very essential to get mastery in C programming. So if you want to learn like why C is best suited for embedded industry, We have our old video on our channel called as C for Champion. So you can definitely check out that video where we have discussed why C programming is most suited language for embedded systems. And you should have some basic understanding of assembly language as well. That will help you to understand processor architecture better. Now, it's very important to know and to understand how peripherals and other component interact with processors, how processor is handling all the data coming to the processor from other input output devices, and that you will learn in hardware design. So I think computer architecture, operating system, hardware design, and the most important part is C programming skill is a fundamental to your embedded system interview preparation. Now let's dive into specific subjects and understand in each particular subjects what important topics we should cover. These topics are very important and must for interview preparation. And once you have solid understanding of these topics, I think you can crack any interview and you will understand more advanced topic in embedded system very easily. Okay, so let's start with the digital design. In digital design, start by understanding number systems. So you should have a clear understanding about hexadecimal, binary, and other number systems. You should not have any confusion between conversion of binary, hexadecimal, and other number systems. This will be your foundation for writing and reading embedded system software. And then try to understand some basic combination and sequential circuit in digital design. Later, move on to finite state machines, and I think finite state machines are very important topic because that will be a crucial building block for any embedded system design. Moving on to computer architecture, first try to get a bigger picture how computing system works, how different blocks in a processor interact with each other. Try to understand what is the difference between microprocessor and microcontroller, how exactly they are different from each other. Once you have all this basic understanding, you can move to particular topics of computer architecture. So start by understanding different blocks in processor architecture. You can start by understanding arithmetical and logical unit, control unit. Then you can try to understand how exactly your instruction is processed by your processor and how you are getting a desired output. And then you can start understanding your processor architecture further by understanding your instruction set architecture, by understanding different kind of registers, what kind of role those registers have during different scenarios in your architecture. Try to understand what exactly is pipelining, what is the difference between CISC and RISC architecture, why exactly we are using pipelining, what we have achieved through it. And then you can also move on to very important topics such as interrupts, timers, clocks. I think interrupt is very important topic, and you should understand how exactly processors handle interrupts, what are internal interrupts, what are external interrupts, and what are the different handling stages of processors for both of the interrupts. And you should also understand what exactly is polling, how interrupts have advantage over polling in most of the scenarios, and also in some scenarios polling will also have some advantage. You can understand that as well. Now let's discuss about memory hierarchy. Memory hierarchy is also a very important topic in computer architecture. In memory hierarchy, we mostly study about different kind of memories and what exactly is their role. So we should understand what exactly is RAM, what exactly is ROM, and why we have used that particular memory in any particular scenario. There are different properties of memory as well. You should understand what is volatile memory, what is non-volatile memory, what exactly is flash memory, and what kind of different flash memories we use in our computing systems, and what kind of secondary storages we use in our computing system, that you can go through. Now, cache is very important topic in memory hierarchy, and cache usually is asked very frequently during interviews. So you should be very familiar with cache related concepts such as cache hit, cache miss, and what exactly processor do during those scenarios. You should also be aware about what exactly is cache coherency and how we can make cache coherent using different protocols. So I think this is all about the computer architecture topics, and if you cover these important topics, I think mostly you will cover everything about computer architecture. Now let's start a discussion about operating systems. Now most of the large embedded system companies have complex embedded systems, and that's why operating system is a crucial part of those embedded system. So there are companies around mobile processors, automobiles, and then right now there are companies around GPUs and server related chipsets, and operating system is a crucial part of these complex systems. So solid understanding of basic operating system concept is must, and interviewer will definitely check your basic OS knowledge. So start with basics. Understand why operating system is required in your computing system. Try to understand difference between operating system and real-time operating system. And then you can move to important concepts in operating system, such as what exactly is program, process, task, and how they interact, how multiple processes are synchronized in your processor, why mutex and semaphores are required, what is deadlock. You can also try to go through some basic scheduling algorithms. Memory management is also very important topic in operating system. Why we need virtual memory, what exactly are pages and frame, what is fragmentation, internal versus external fragmentation, and how we can avoid that. What is segmentation? All these are the important topics in operating system. So everything is covered in the resources part. We will be discussing in the next video. Here we are just getting an idea about each and every subjects and important topics. So you should get a clear understanding of what kind of preparation you need to do during your next 3 to 4 months. Now moving on to the programming. For embedded system, C programming is your most important skill, and you need to master C language, because C is the foundation of almost all embedded systems in our industry. Along with that, you need to get familiar with assembly language as well. It will help you to understand low level operation, like what exactly is happening in the hardware when you give a particular command through your C code. So for embedded system, focus on these particular topics for interview. I think storage classes and important keywords are frequently asked in interviews. So learn about different storage classes like auto, static, extern. Try to understand what are their scope and lifetime in your program. Also keywords such as volatile, constant, you should have good understanding about those keywords. You should have practical understanding of your keyword, because these keywords are very important for your embedded software development. Now in C programming, only 4 or 5 topics are very important. So storage classes and keywords we have already discussed. Other topics are functions, pointers, structures, and bit manipulation. So functions, like you get good understanding of function, get understanding of function pointer as well if possible, and because functions are very important for any software development. Function allows you to write reusable code, and that is very important in big embedded software development. Now pointer is most important topic in embedded system, because with pointer you can manage memory, you can manage hardware directly. And that is what we do in embedded system. We try to manage hardware, we try to manage memory by our software. So pointer is most important topic, so we will discuss in next video how we can cover pointer and what exact resources you need to be followed to get a good mastery in pointer. Now bit manipulation is also one of the most important topic in C language, because in embedded system you will often work at a bit level. So learning how to manipulate bits will help you to interact with hardware more efficiently. So you can get a particular value from your memory, you can get a particular bit of a register, you can set or unset a particular bit of a register by using bit manipulation, and these are the common practices we follow in embedded system. So bit manipulation is very important. Now you can also get some basic knowledge of Python, because Python will be used for automation kind of purposes during embedded software development. And if you have knowledge or good skill set of Python, that will be bonus point for you. Okay, so let's now talk about embedded system design. Here you have to cover both hardware and software aspects. So basically in embedded system design, you will be designing your systems around a particular processor. So processor will be your main hardware in overall computing system you are going to develop. Now one suggestion here is that if you are absolutely beginner, try to do some basic projects using Arduino or Raspberry Pi. But if you want to get a good embedded system design understanding, I would suggest to try with ARM based CPU. So you can pick a microcontroller of STM32 Discovery series. Those microcontrollers are based on ARM processors, and you can do all your projects experiments on that particular microcontroller, because ARM processors are widely used in industry, and if you have a good understanding of ARM architecture, and I think that will add a good weightage in your interviews. So as processor is your main hardware, try to understand everything about your processor. Try to understand all the theoretical concepts which you have studied in computer architecture with respect to your processor. Understand what are registers, instruction set architecture, how pipeline is implemented, how caches are implemented. This kind of simple basic topics you can try to understand with respect to your processor. Understand how memory map is defined for your processor, how bus architecture is defined for your processor, because that will be very important topic you need to cover, because that will be base of how clock generation is happening in your processor. So clock generation is very important, because if you want to configure, or if you want to initialize any block in your processor, let's say you want to configure a GPU, or you want to initialize a UART block for your CPUs, you will require clocks to be turned on. That's why clock generation concepts are very important. If you have covered all these basics, one more important topic you have to cover respect to your processors are how interrupts are handled by your processor, how both internal and external interrupts are handled, what is the importance of register, stack, vector table while handling those interrupts. Also, there will be some predefined exception for your processors. Try to understand them, try to understand why exactly they are defined, why their priorities are defined, and how you can use those exception for your software development. So if you want to cover more about hardware aspect, you have STM32 microcontroller. Try to understand what kind of different hardware is there on that board along with your processor, and that will give you a good understanding about what other hardwares, what other components are required to form a overall computing system. Now moving on to software aspects. So basically embedded software is nothing but writing a driver or command to make your hardware do something that you desire. So if you want to do that, programmer's model of any architecture is very important. Programmer's model is nothing but a document which will contain all the information with perspective of programmer. It will contain all the details of what you need to do or what you need to program by your software to make hardware do something that you desire. For example, let's say you want to configure any GPIO. So there will be set of registers you need to write, and you need to write them with a particular value. This all information will be available in programmers module. So I would suggest here that just try some basic exercises of configuring a GPIO or configuring a clock, and that will give you a good understanding of how this model you have to use for your other implementation. These are the hardware and software aspect. One more important topic, and which is very interview favorite, is communication protocols. And I have observed in many interviews communication protocols are asked very frequently, so you can go through some basic protocols such as UART, SPI, I2C. Try to understand their merits and demerits over each other. Try to get practical understanding, because interviewers will try to give a simple embedded system design scenario to, and they will try, and they will ask you to choose any communication protocol among these, and they will ask you why you have chosen that particular protocol and what exact reasons you have, so that this protocol will be best suitable in this scenario. So you have to understand them practically. So I think these are the topics you can cover as part of theoretical concepts of embedded system design. Now in this subject, some practical implementation or hands-on experience is very much required. So there will be fourth video in this series that will be fully dedicated on this discussion only. We will discuss about how we can start to get a good hands-on experience with embedded system design, how we can implement some basic peripherals such as some temperature sensors or something like that, and how we can get a good understanding of how we can design a system, how we can write a code for basic implementation, and that will make a base for you to do big projects. And we will discuss everything about this in the fourth video. We will discuss about what kind of resources you need to follow from the beginning to cover all these aspects, and we'll try to discuss about some projects as well, so you can check out that video. So I think this is everything about embedded system design. So now let's talk about the last section of this video, and let's discuss about what are the different kind of tool chains you need to get familiar with, because tools will be your bridge between what theoretical knowledge you have and what exactly you can implement. So interviewer will definitely try to understand how good you are familiar with different kind of tool chains. So let's start with build systems. Now in embedded system, you will be mostly working on low level. So you should have good understanding about how exactly your binary is getting formed and how that binary is interacting with memory. So get familiar with all the stages of compilation, and try to understand how exactly linking is done, how exactly your executable is getting formed. Along with that, try to go through memory section of your C code. Try to understand how different part of your C code is getting laid out into the different sections of your memory. Now, one more important thing is just get familiar with how you can write a simple make files, because in industry you will be handling big projects, and compilation and linking will be complex and cumbersome if you want to do it manually. So make files are your go-to tools, and you should definitely know how to write simple make files. Interviewer can ask you to write simple make files during your interviews. Along with that, just get familiar with a version control system. You can just try to understand Git, because yeah, you know the reason. You will be collaborating with different teammates while working on a big project, and this kind of version system knowledge will help you to collaborate effectively. One more important thing is to understand debugging tools and to understand debugging approaches. Now you can start with simple debugging tools like GNU debugger. Just try to debug your C code. Along with that, there will be different compilation error, runtime error, segmentation fault, or stack overflow. Just try to understand why those errors are coming. If you have made any mistake while writing any C code, try to understand how you can debug those errors, what are the solutions for those errors. Along with that, you will be doing different projects on your discovery board.
So you will get many failure scenarios. Definitely you will write some bad value to any register. So try to debug those things. For this purposes you can use kill microvision software. You can develop your c embedded system software on that particular software. And that software have very good user interface for debugging. You can see different sections of your memory. So then you can start trying different kind of experiments with your code. You can try to write some c commands, and you can see what exactly is happening to the memory, uh, how registers values are changing. So I think that those kind of debugging approaches will be more than enough as a beginner. So definitely you should understand these debugging tools, and try to get familiar with different debugging approaches. So I think so we have covered everything from basics of digital design to computer architecture. We have also covered what OS topics you should cover, how you can get a good with embedded system design, and what kind of tools you should get familiar with. I think this is more than sufficient for a beginner to crack any interview. And so we in the next video we'll be discussing about all the resources you'll be required to complete your embedded system interview preparation. So stay tuned, and if you like our efforts, please give it a like. That will help us to reach out many more other people. If any experienced engineer is watching this video, please leave your suggestion if you have any. And you can also give your feedback, or if you have any question you can post in the comment section. So let's meet in the next video.